this hand, please.
Okay, so 1, 2, linear measure. We see the word linear. What do you know we're going to be talking about today?
Lines.
So we're going to be talking about lines. So keep that in mind. We're going to be talking about measures of lines. Can you measure an actual line, like the entire line? Did you ever measure that? Why not? Yeah, it's infinite. It goes on forever. So we can't put an actual number on there. So we're going to have to split these into smaller things that we can actually measure. The things that we'll measure would be line segments. Like Austin just said, I can't measure an actual line because it's infinite, but I can measure something called a line segment that's part of a line. It's got 2 endpoints, and then all the points that are in between those. Part of a line, 2 endpoints, and all the points in between those. So that's what a line segment is. So if we were going to draw one of these, I want you to do this with me. I'm going to start. Well, it would have been a line, but instead of putting the arrows at the end, I'm going to put a point here, point here. So let's say that's point A, that's point B. That's what line segments look like. Okay. So I've got an endpoint and when I name this, I'm going to name it a lot like I named a line, but I don't have as much choice. I have to use the endpoint. So I would call this AB, and then over the top, I'm going to put a line, just like that. Yes. And why am I not using the arrows this time? So that's how you're going to be able to tell what they're talking about when they show you the symbol for the name. If it's got the arrows at the end, it keeps going. No arrows at the end, it's talking about just the segment. When we talk about the measure of line segment AB, it's always written as just capital A, capital B. So that's another way that we can symbolize this, and it means something different. If I put the line over the top, I'd read it as line segment AB. If there is not a line over the top, I read it as the measure of AB. Okay? So the line over the top talks about the physical, actual line segment. If I don't put that, that'd be like me saying measure of AB equals 8. Something I can actually assign a number to. I wouldn't say that the line segment equals 8. I'm going to say its measure equals 8. Something that we already kind of touched on when we talked about lines and how they're infinite. Betweenness of points. For any 2 points, there is another point between them. Doesn't have to be exactly in the middle. It just says that if you've got 2 points, you can always create another point that's in between those. And keep in mind, between does not mean in the middle. It can, it just doesn't have to. So once you get that, draw part of the number line. Say this starts at 0 and it ends at 1. If I did choose to go right in the middle, where am I going to be at now? Half. And if I go between 0 and a half, quarter. If I go between 0 and a fourth, I'd be at an eighth. Can I keep going? And now I'm down to a 16th, then I'd be down to a 32nd, 64th, 128th, so on, so on, so on. Would I ever really be done number-wise? No. There's always going to be another point in between any two. And it doesn't matter how small I get. Can I always get smaller? Yeah. There's never, ever an end how small you can make those fractions. Just keep making the denominator bigger, keep getting smaller. Here's a way that we can use that kind of simple idea to end up solving for some things. If you have some point M between points P and Q, that's true if and only if P, Q, and M are, first of all, collinear, and PM plus MQ equals PQ. I'm going to go ahead and sketch this one out for you too. So once you have this drawn, or sorry, written, go ahead and draw this with me. Line segment M is between P and Q. Is M right in the middle? No, just in between. Not exactly halfway between, but this would still work even if it is. The easiest way that I could say this, in other words, you may want to write this down if that was kind of confusing. Look at PM. Then look at MQ. They're both parts. And what this is saying is if I add the part plus the part, what do I end up getting? The whole thing. Part plus part equals whole. And that's a really simple idea, but it's one that we're going to use over and over again in this course. If I take something and I split it up into parts, in this case 2 parts, if I add those parts together, I'm going to get the whole thing. It's pretty simple, but it's going to allow us to do quite a bit. That would be like, let's say I know that this is 4 and I know that this is 11. What does that mean as far as how long PQ is? If this is 4 and that's 11, PQ would have to be 15. So write that down. So that was a case where I do a part, I add them together, I got the whole thing. What if I knew the whole thing in one part? Let's say I told you that PQ this time is 18, and I told you that PM is 3. Could you figure out how long MQ is? Yeah. This time I've got the whole thing. I've got one part. To get the other one, I would subtract. So 18 minus 3 tells me that MQ equals 15. So you can go that way with it as well. You've got to kind of identify what you have to begin with. Do you know both parts? You know one whole and then the other part? What do you got? And then just work with it. Word that I think you've seen before, and if not, you'll get really, really familiar with it because it's one that you will see over and over again. Congruent. This time, congruent segments, we're just going to say they have the same measure. They have the same measure. We talked about the co-prefix a little bit already. What did co mean from before? See how it's popping up again? Co means same. Congruent means same measure. And that's what the definition basically is, same measure. So use that prefix to help you remember what it is. Go ahead and draw 2 segments with it. We'll make segment AB. And then we'll also make a segment CD. Try to make them the same length as best you can. Mine probably don't look it either. That's what we're going for. 2 segments of equal length. Now I name these, and again, I name them using the endpoints. I don't really have any choice here, though. AB. And then here's the symbol for congruent. It's an equal sign, a squiggle up above it like that. And it's congruent to CD. That's the symbol for congruent. That tells you that 2 objects have the same measure. In this case, segment AB is congruent to segment CD. Yeah.
What does it mean when there's 2 squiggly lines for the equal sign?
Approximately. You mean like this?
Yeah.
That's showing that, like, let's say you got that x was 7.1472, something, blah, blah, blah. If you rounded it, you don't want to necessarily say that it's equal, so that means approximately. That's a way to indicate to someone that your answer's been rounded. And what that means, again, that is saying that AB equals CD. So write that down as well. Those are 2 completely different statements. They're very related, but they are telling you different things. The top one said that the segments were congruent. The bottom one says that the measures are equal. So you would read them differently. This one would be read as segment AB is congruent to segment CD. This one, measure of AB equals measure of CD. Constructions we're going to talk about today, and then we'll do a few of them next time. Constructions are drawings of geometric figures made without measuring tools. Made without measuring tools. We may do one today if we have time. We'll see where we're at. So if it's something that you'd use to measure, you do not use it when making construction. Such as you do not use a ruler. What do you call the thing that you use to measure an angle? Yeah, so you don't use protractors. There are no rulers, no protractors. You can use a ruler like maybe as a straight edge, but you won't actually use it to measure anything. So typically, and what we'll do in here, they're made using a straight edge, which could be our ruler or edge of your book, or edge of your notebook, whatever. A compass, and a pencil. Those are the tools that we'll use in here to make those. A straight edge, a compass, and a pencil. You know what the compass is used to make? We use those for.
Circles.
Yeah. It's what you use to make a perfect circle. Then sketches are made with no tools. Sketches are made with no tools. That's kind of important to keep in mind. Make sure you're paying attention to the directions so you don't end up doing more work than you need to. If they tell you make a construction, use the tools. If the directions say sketch, you don't need to use a straight edge, you don't need to use a compass, sketch it. And typically what I do off on the board, that's going to be a sketch. So if they tell you to sketch, I do not expect it to look perfect. I don't expect you to necessarily use a ruler. You're free to if you want to, but you do not have to in those cases. You're just going to illustrate what it looks like and get that idea in paper. First part of the homework's up there. We're going to kind of split this up a little bit. You got page 18, 1 through 8 all, 10 through 32 evens, 46 through 54 evens. We're going to go ahead and do 1 through 8 together now. And then once that's done, we'll go back and we'll finish the next section and do the same thing there. We'll start with page 18, 1 through 8 all. 10 through 32 lines. Don't put your notes away yet, but you can go ahead and get out the paper that you're going to do your homework on, and then get your books open to that page and start looking at it. So first one here, we are measuring what looks like a goldfish of sorts. All we gotta do is look at it. They've already put the ruler on paper, and then we just name our answer. So when we look at that, Nick, what's that look like to you? On number 1, what's that look like to you as far as measurement?
5.8 centimeters.
5.8 centimeters. Everybody agree? I think I do too. So 5.8 centimeters, and thank you for using a unit. Have that on your answer. Don't just write 5.8. I want to know 5.8 what? Second one. Alex, what's that look like? Yeah.
3.5.
Yep, 3.5 centimeters works for me on that one. Third one, before you answer, kind of be careful. What do we switch to? Inches. So look at how many dashes there are there. What do they split those inches up into? 16ths. So look at it. Go ahead and jot down an answer for number 3, and then I'll give you mine in a second. Look at it on your own. Jot down an answer for number 3. Keep in mind, each little line there we just said was a 16th. What are we thinking? What?
Inch and 7/8.
I would agree. So 1 7/8 inch. Now the next one, they split it up into 16ths. No, and I almost kind of wonder if it's a typo in the book because they split that inch up into tenths, and do you usually do that?
No.
No, usually inches stay with 16ths, so that's kind of weird. But look at it; it'd be 1 point. Somebody shout it out. 1.3. And again, inches. So when you're working on your own, 10 through 13, same thing. Number 5. Find the measurement of each measure. Assume that each figure is not drawn to scale. That second sentence will not always be given to you, but it is something you must always keep in mind with this. They do not have to draw things to scale. So just because things look equal, should you assume they are? Unless they tell you they are, do not go with that. Don't make any assumptions. On number 5, what are we trying to find? CD. Would that be the part or a whole thing? So what am I going to do with 2 parts? Add them together. So I'm going to take 1.1 plus, what is it, 2? Okay. Add that together and I would get? So I want you to put your answer as CD equals 3.8. 3.8 what? Inches, right? Next one, number 6. Am I doing the exact same thing? What's different about it this time, Matt?
It's only 1 part.
So what do I do with the whole and the 1 part I do know? Subtract them. So I would take the 4, the whole, minus the 1.6. So what does that tell me about RS? Say it again. 2.4? 2.4 what? 2.4 what? Centimeters. When you're on your own, 14 through 19, very simple. Last 2. Not really any different, just this time, what do you notice you have in your parts there? Just new. I got some variables this time, but the work does not change. Part plus part equals whole minus part equals part. So keep that in mind, it doesn't change anything here. So for 7, they've given us CB, BD, and BD. So we're looking at that figure there. So find the value of x and BC if B is between C and D. So they didn't give us a drawing, so I'm going to go ahead and make that first. So copy this with me. B is between C and D. So C and D are my endpoints. B is somewhere here in between. If you're given a problem like this and they don't give you an illustration, make it yourself. That has to be your first step. Okay? Because if you're not doing that, it makes it a lot harder to figure out what's going on, what's going to go where. If you take the time to draw it, it makes the problem so much easier. Now that I've got that, I'm just going to go ahead and write down what I know. CB, this piece here is 2x. BD, this other piece is 4x. And they also told us that BD was 12, which really simplifies the whole process. What? Yeah, so 4x has to equal 12 because that's the same thing. Divide by 4. X does equal 3. Now we're also supposed to find the length of BC. So that would be this piece right here, correct? So how long is BC? Yeah, and now we're done. Any questions on that one? Okay, one more. Number 8. Do I have a drawing? No, so I need to make it, but I'm going to use the exact same one I just did. We've got C, B, D. We're still under the same set. Now we're just going to label it. CB is 4x minus 9. BD, 3x plus 5. And CD, the whole thing is, how long? 17. How can I set this up? What do we say is true about part plus part? Equals the whole. So I'm going to set up my algebra equation. Part plus part equals whole. So 4x minus 9 plus 3x plus 5 equals the 17. Here's an example of why we practiced our algebra before we got to this first chapter, because this stuff's going to pop up. So we're going to remember, when there are variables together on the same side, how do I get them together? In this case, add them. 4x plus 3x would give me, how about the negative 9 plus 5? So that was my first step. I simplified a little bit by combining my like terms. Any questions on that so far? Okay, now we're in algebra mode. How do I get the x by itself? Okay, first step, I want to add 4 to both sides. So 7x equals 21. Last step, and x equals 3. Am I done? Because what else does this problem still want? Which one do they ask for? Look at directions. Only one of them. Find x and BC. So that was the 4x minus 9. So I'm going to do 4 times 3 minus 9. 4 times 3 minus 9. So BC also equals 3. Now it's done. On a problem like that, make sure you're answering both parts. Pretty regularly, you're going to see that in this kind of class. Often you're going to find the variable first, then you're going to plug that back in to find something else. So if you just told me x was 3, that's not going to be right. So make sure you don't lose points for just not doing the easy part.